Okay, everyone, thanks for joining us for this webinar today. And as you know, we're dealing with the COVID-19 situation, so I wanted to make sure that we were still hosting meetups. And one of the benefits of having a virtual meetup is we get to have people from around the world join us rather than just people in our local community. So today I have the pleasure of having two wonderful guests as part of the Denver meetup. And we have Dan Selman from clause.io, and he heads up the Accord project, and they're really doing some great work around smart contracting, and it's really been one of the shining stars of Hyperledger as a project. And then we also have Nicolas Maurice from PegaSys and Consensus, and he's going to talk about the work that he's doing with Orchestrate, and then also he's with PegaSys and part of Hyperledger Besu, and we'll talk about how we can leverage Hyperledger Besu and integrate with Orchestrate. So at this point, I'm going to go ahead and turn over the webinar to Dan. And Dan, you want to kick us off? And what I look at for this is going to be a 1-hour virtual meetup. And Dan, if you want to kind of walk us through for the first half hour, maybe 20 minutes or so of presentation, and then a few minutes of Q&A. And then Nicolas, if you want to take it from there and go through with another 20 minutes and maybe 10 minutes of Q&A. Sound good?
Sounds great.
Okay, Dan, so go ahead and take over.
All right. Can you hear me okay, John? Audio good?
Audio sounds perfect, Dan.
Great. Video okay?
Yeah.
I think you need to allow me to share my screen.
Okay, I'm going to stop share. There you are.
Perfect. All right. Can you see my slides okay?
Looks perfect.
Lovely. Good evening, everyone. It's 8 p.m. in the UK. I have no idea what time it is where you folks are. But thank you very much for taking time out of your day to come and learn about the Accord project and the work that we're doing with BSI PAS 333, which is the smart legal contracts specification that we've been working on. So this is the agenda. A very brief intro to what is the Accord project, because I'm assuming that not everyone has heard about us, unfortunately, and I'll give you a little bit of an overview about what we've been up to for the last 2 or 3 years. Similarly, on the BSI, just a brief intro on the kinds of work that they do, particularly in the standards space. I've one slide on the benefits of standards, and then we'll really get into the meat of the presentation, which is an overview of the work that we've done on the PAS. And then finally, the call to action, as is quite common with a lot of these open source initiatives, is really to get involved. So I'll finish with a slide that will give you some pointers for hopefully how you can engage with us. And yeah, so my name's Dan Selman. As John kindly said, I'm the CTO of Clause, but I'm also very involved with the open source community, both within the Accord project, which is a Linux Foundation project, and also at Hyperledger. And John has been a great friend to the Accord project, and one of our active community members. So I'm thrilled to be here today to kind of fly the flag for the Accord project a little bit and explain what we've been up to. So I've got a pretty varied background, but primarily in big enterprise systems. Prior to Clause, I was with IBM, working on mostly business process automation. Slides out of order, interesting. So the Accord project, as I said, we're a fellow Linux Foundation project. We're a top-level project, and our mission is to work on open source legal technology, which is a pretty broad kind of a mission. But we want to work on a set of software libraries that can really help people that are working at this intersection of legal and technology. And I'll show you some examples of that. But fundamentally, one of the issues that we have in this space is that there's a real lack of kind of common file formats and standards. And there's a lot of vendors working on products kind of essentially in silos, and therefore interoperability is a real issue. And part of our mission is to collaborate with other groups and standards bodies. And really the work that we did with BSI is a manifestation of that desire to not only write open source code, but also think about, well, what does this mean from a specification point of view and a standardization point of view. Yeah, as I said, we've been going for over 2 years now. We have a very active community. I think we're up to about 200 contributors on GitHub. We have over 12,000 people on the Accord Project Slack, and a wide variety of stakeholders, both on the technical side, but also on the legal side. So it's a really fascinating place to work because it's this kind of mashup of people with strong opinions about their side of the world. And when you get them in a room together and you get them talking, that's when the magic happens. So there's probably some technology logos that you recognize. So now, a word about BSI. So BSI is the UK national standards body. It has the distinction of being the oldest national standards body in the world. It was formed in 1901 by Sir John Wolfe Barry, who was the designer of London's Tower Bridge. So back then, everyone was a polymath, it would appear. And the first meeting occurred on the day Queen Victoria died. And it was to set a standard for the types of steel that they were going to use when they constructed the tramways. And the BSI kite mark is a pretty famous kite mark in the standard space. Obviously, people more familiar with it in the UK than elsewhere. But because they are the world's oldest national standards body, they've had a lot of influence on other standards bodies that have come along since. And as you can probably tell, I'm based in the UK, so it makes sense for us to work with a national standards body here. So very briefly, the benefits of standards. So they're a tried and tested mechanism to promote good practice, and that cuts across a broad range of factors. Depends on the industry you're in, and obviously in technology, not all these may apply, but it's things like improving performance, cutting costs, really kind of baking best practice down into something that's widely accepted. And that's something that's somewhat lacking in the legal technology space. There's a lot of people doing lots of interesting work, but it's quite fragmented, and the risk is that people will reinvent wheels unless we try to put some structure around it. So what is a PAS? A strange acronym. So PAS is it's a BSI acronym. It stands for Publicly Available Specification, and often it's like the first step in a standardization journey. So they call it a fast track standardization document. And essentially what the BSI does is they facilitate the authoring of this document. So they put together a group of industry experts, and the industry experts work with a technical author. In that case, that was myself. And over a period of months, kind of in a closed environment initially, you refine the specification, and the BSI provides a sort of an editor that helps you draft the specification and makes sure that you're kind of adhering to their format for writing a specification. You know, there's various stylistic and language conventions that the BSI uses. And the goal is to define good practice. And it could be for a product, a service, or a process. And it's a good way of kind of taking a snapshot of a space that might be moving quite quickly and where there might be a lot of innovation. And that's certainly the case in legal technology. You know, by getting a bunch of stakeholders into a room and having them collaboratively work on a document, you learn a lot. And the phase that we're in now is that this document is now entering public review, where anyone can create an account on the BSI site, can download the document, and can start to comment on it. So this is like an important and exciting milestone for us. And yeah, we're really hoping that we'll get some good feedback from the wider community. It's important to point out that a PAS is not a BSI standard. It's like the first step, or potential first step, to becoming a standard. But it is a fairly formal document that's authored through a fairly formal process with, you know, hopefully a wide and representative range of stakeholders. So they can be quite influential. So let's talk about the goals. I won't read all this because I kind of lifted this from the introduction of the PAS. You can read it at your leisure. But the goal is, there several fold. There's definitely a taxonomy kind of a goal here, in that there's a lot of people in this space that use a lot of words and they use them in slightly different ways. So as you can imagine, you get a bunch of people in a room, you actually spend quite a lot of time talking about, well, what do you actually mean by contract, or what do you actually mean by an obligation? You know, all of these kind of slightly loaded words, and that's a challenging thing to do in this space in particular, I think, because a lot of the words that technologists use have a meaning, and a lot of the words that the legal folks use have a meaning, and they often don't line up. Right? We use the same words, but we use them in quite different ways. So one good example of that is the word execute or execution. So, you know, when we talk to programmers, execution has a very kind of definite meaning, right? We might execute some code. But when you talk to lawyers, they execute a contract. And that means everyone has signed the contract. So, you know, there's a few meetings to kind of get through that and understand where everyone's coming from. And therefore, there's a not insignificant part of the document, which is really about just defining some terms, so that if a legal person is reading this document or a technology person is reading the document, we know what we're talking about. The other thing that we want to try and do is we want this to be technology agnostic. This is not a blockchain spec or a cloud spec or a mobile spec. Really what we're trying to do is we're trying to define a set of kind of signposts or principles that can then influence technologies in lots of different areas. So kind of by necessity, it's fairly high level. You know, you're not going to get like a grammar or something out of it that you as a technologist can start to code up. It sits really above that. It's a higher level of abstraction than that. We also want to kind of use it to illustrate, well, why is this important? You know, what can it do for the legal industry, for the technology industry? So there is an aspect to the spec which is kind of explaining the art of the possible, if you like, and why this is an important journey that we're on. And you know, finally, there is a bit of work in the spec around obviously deploying two technology platforms. You know, this is not supposed to just be a kind of a philosophical or abstract exercise. we want this specification to guide vendors as they build solutions. So they can sort of refer to the specification, and it would influence potentially some vendor products in this space. So there are some fairly concrete aspects to it that I'll talk about a little bit. So the scope. So first of all, there's quite a lot of work in the spec on, well, what is a smart legal contract? What do we really mean by that? What are the components of a smart legal contract? Who's it for? How might they interact with it through its life cycle? And the PAS defines a smart legal contract essentially as a combination of natural language, data model, and logic. And it doesn't specify how those things are defined. You know, you could write your logic in Haskell or Solidity or Java, or, you know, you could invent your own language. Similarly for the data modeling, and similarly for how you capture the natural language. But there is this concept that there is a sort of a virtuous triangle, and something, you know, something rather magical happens when you bring these three things together and you can manage them as an artifact. And that's sort of fundamentally what we refer to as a clause in the PAS. And a smart legal contract is composed of a set of clauses. And point two is it's explicitly cross-platform and kind of technology agnostic. So it's not a spec for just Hyperledger blockchains or even just blockchains in general. Because we know that smart legal contracts, to get widespread adoption, they might have to run on your mobile phone, you know, inside your cloud SaaS application, on your desktop, in your blockchain, and whatever comes next, right? This is intended to be a set of principles that could outlive maybe our current technical choices. It explicitly doesn't cover some stuff, which is also, you know, interesting stuff, challenging stuff, but, you know, you have to sort of set a boundary. So it doesn't cover the process of negotiating a smart legal contract or interpreting or enforcing the legal elements of a contract. So it's quite narrowly focused actually on what is the natural language, the model, and the logic of a contract. It also doesn't address things like oracles and how do we assess the trustworthiness of data that goes into a contract. That's also sort of explicitly ruled out of scope for this specification. And it's primarily targeted at software vendors who are interested in building compliant implementations or solutions that sort of reference this specification. However, it's also of interest to people that want to build these templates, sort of content providers, if you like, in this space. So you could imagine you're a law firm, a forward-looking law firm with a legal technology department, and instead of just sending your client a Word document, perhaps you want to send them some other type of artifact that has got more semantics and has a data model and could potentially have some executable logic inside it. So graphically, within the Accord project, it looks something like this. So on the left, we have a legal contract, which looks very traditional. It's got a bunch of English language, in this case, that the computer can't interpret. But embedded within that document is a clause. And that clause has much more formal semantics. So the language is somewhat locked. The data model that sits behind the language has been defined. And via those two things, you can write some logic that also sits behind the text. And that's what you see in the AP, the Accord project manifestation of the triangle. So we have three projects at each corner of that triangle. The data modeling project is called Concerto. The logic project, which is a domain-specific language, is called Ergo. And the markup language, if you like, for capturing the natural language It's called Cicero Mark. So a smart legal contract is perhaps a 50-page traditional contract with certain clauses that have been embedded and have these higher level semantics. And that's kind of a pragmatic decision. Our belief is that most contracts will have legal text that's primarily for human beings, and that computers will probably never fully understand, or there isn't a lot of ROI in making the computer understand it. But there are specific clauses in the contract, strategic clauses, potentially about things like acceptance of delivery, when payments should be made, how payments should be made, that we can make essentially deterministic, and we can make computable. And therefore this specification is focused on that problem. It's not trying to come up with a computable, readable representation of all contracts or all parts of all contracts. It's focused on sort of digitizing specific clauses that have a high ROI in being digitized. So if we drill down a little more into that triangle, you get sort of a UML style diagram emerges, where we break down some of these concepts. So excuse the poor quality diagrams. They will get redrafted for the final version of the spec, but these are sort of our working diagrams that we can iterate on very quickly. So we have that template concept that sits in the middle, and there are two types of templates. There are contract templates that represent the whole document, and then there are clause templates that sit within a contract template. A clause is an instantiation of a template. So if I go back to my previous slide, this acceptance of delivery clause here has been parameterized with variables in blue. You can see party A, party B. When we supply those variables, we're instantiating the template and creating a clause. And a template has logic, a data model, and a template grammar, or the text for the template, as I indicated. And then it has some metadata, versioning, naming information, so that you can actually manage this template as a software artifact, essentially. Hopefully that makes sense. And then there's a runtime view of this world, which is kind of optional, actually. You can get a lot of value from just digitizing the contract. It gives you a formal representation of the clause. You can then extract the data for the clause because you've digitized it. But if you go the step beyond and you provide logic for your template, then you can start to send runtime data to the template so that it can perform calculations and start to influence the outside world. But the principle in the specification is that the logic for templates is a pure function from a kind of computer science point of view, which means that the logic receives requests from the outside world and it produces responses to the outside world. And that's kind of a synchronous request-response kind of relationship between a client and the template logic. And then the template logic can optionally emit obligations, and those don't go back to the client. So if you wanted an example, maybe I've signed a contract to deliver some goods to John, and the contract says if I deliver them late, then I owe John some money. So we could connect this clause to our blockchain or our IoT system, or our freight management system, whatever it was, and the status of the delivery would be continually updating the state of the contract. But when the delivery arrived late, at that moment the contract would emit an obligation which said, unfortunately, Dan, you now owe John the delivery penalty. So that's the general programming model, kind of functional with this synchronous request response channel, and then an asynchronous event emission channel. And that seems to map quite well to a lot of the problems that we're seeing in the space. And it's sort of designed, of course, to, fingers crossed, integrate fairly naturally with a pretty broad range of deployment topologies. So you could imagine that this clause gets packaged up into a AWS Lambda and it runs there, or you could imagine that it gets deployed to a blockchain and it runs there. We're trying to keep as many options open for people. And I think I'm approaching the end now. There's also some informative text towards the end of the specification where we walk people through, well, how in practice do we actually create one of these things? Because that's an interesting and new exercise for people. And it's kind of interesting because it requires some legal expertise and some technical expertise. If you look at a clause like acceptance of delivery, as a technologist, we might have perhaps an assumption about the semantics of this legal text, but actually to get into the details, you probably need to talk to a lawyer who really understands the semantics. But obviously they don't have the programming skills to necessarily capture those semantics in something that a computer can understand. So we need to bring those two stakeholders together to create one of these templates. And that's sort of what this little process flow walks you through. So you start by analyzing the legal text and the semantics of that, and ultimately you really need to understand that. And in some cases, you will conclude that this legal text is ambiguous and it can't be crisply or deterministically captured for a computer system. And at that point, you either have to make some assumptions and make it crisp and deterministic, or you may decide that actually this is not a good target clause to digitize, and you'll stop there. Then you'll provide some metadata. So you'll decide on, well, what's the name of the template? What's the version? Who's going to manage it? Keywords, all that standard kind of stuff. And then you'll start to work on capturing the grammar for the template. So what is the natural language for the template? And where are the variables within that natural language? And once you've punched holes in the natural language and you've defined where you want your variables to be, then you need a type system. So you need to tell essentially the spec, well, variable 1 is a date, variable 2 is a monetary amount, variable 3 is the name of a party to the contract, variable 4 is some other concept that I'm defining for this specific template. So you get the idea. So through that exercise, a data model will emerge. And then you look at the logic of the legal text, so the semantics of that text, and you decide whether you want to automate any aspects of the operations of that logic. So, for example, if the logic is not deterministic, you're probably not going to capture it and digitize it and write the computable representation of it. And so, therefore, you may stop there. So you've captured the structure of the text and you've defined the variables, but you're not going to write the code that sits behind those variables. And there's a lot of value in just doing that, right? Today, when people buy contracts, sometimes they buy them as Microsoft Word documents with those placeholders punched in them. But they're very hard to operationalize today because all of those placeholders are strings, essentially. So the type system allows you to extract more value from the template. But let's assume that it's deterministic and there's ROI in actually automating the operation of that logic. So you'll go to the next step, which is to start to capture that logic in a using some sort of a programming language. And we don't go into the details of exactly what sort of language you would use, though clearly there are some languages that would have more favorable properties than others, particularly in terms of things like formal verification, for example. You probably don't want sort of null pointer exceptions coming out of your legal contracts, things like that. And then you're done. And the call to action, as I said, PAS 333 is open for public review until May 5th. The hyperlink is there. I'm sure we'll share the slides with John afterwards. So you do have to create an account on the BSI site. Once you've created an account, you can see the PDF and you can actually comment on the PDF on their site. And all of those comments, they reach us as the technical authors. And after May 5th, we will spend the summer. It's probably a good quarantine job. I think we've had over 100 comments already. We'll go through all those comments and update the specification. And hopefully we'll build a stronger spec by the end of the summer. Encourage you to get involved with the Accord project if this is the sort of area that you work in. As I said, big, vibrant community, over 12,000 people on Slack. But please get involved. We have weekly technology calls where we talk about all sorts of geeky modeling and compiler stuff, and even user interface development to support these projects. You can read about those at docs.accordproject.org. And of course, we always welcome pull requests, and we'd encourage people to become contributors. And that is what I have. Hopefully I didn't run over too much.
No, you did great, Dan. We really appreciate it. And if you want to just turn back over the screen to me, that's wonderful. And then what we'll do is we'll take questions from both presenters after we wrap up the presentation by Nicolas. And one of the things that we have is a challenge. I'll turn on my video here. One of the challenges that we have is really when you're doing a virtual meetup during a work week, you need to stay on schedule. So at this point, I'd like to turn over the meetup to Nicolas, and he'll go through and give us an update about what they're doing with Hyperledger Besu and the Orchestrate project. But thanks, Dan, appreciate it.
Thanks a lot, John. Thanks a lot, Dan. Can you see my screen? Yes. So I'll quickly start by introducing myself. So my name is Nicolas Maurice. I am based in Paris. It's 9:30 p.m. right now. I joined Consensus end of 2017, first as part of the professional services team in the Consensus, and I've been working as a technical lead and blockchain architect for some enterprise project we had, for example, with BNP Paribas, around tokenization of mutual funds. 1 year and a half after I joined Consensus, I co-founded PegaSys Orchestrate, so which is the topic of today. Prior to Consensus, I've been working at the EY Innovation Lab in Paris, and my academical background is engineering. So thank you very much all for your time today. I hope you are all safe in those particular days. So during this presentation, I will first quickly speak about Hyperledger Besu, maybe as a reminder for all of us, and maybe to remind also how we can contribute to Hyperledger Besu. And then I will more focus on Orchestrate and how it interacts with Hyperledger Besu. So I will be basically listing some features that are covered by Orchestrate. Those are the features that we have been meeting during various projects that we have building blockchain platforms, and why those features are important. So first about Hyperledger Besu. So Hyperledger Besu is an open source Ethereum client. It's written in Java under Apache 2 license. So one of the main specificities of Hyperledger Besu is to be compatible with both Ethereum public and private permission networks. So we currently have some Hyperledger Besu nodes that are connected to the Ethereum mainnet, while some other users are creating private networks using Hyperledger Besu. So it provides what we used to name enterprise features. So for example, around permissioning, around privacy. Also, Hyperledger Besu is extendable with plugins, and it provides simplified deployment and monitoring. So this is a high-level picture about Besu. Maybe a more technical picture here that will introduce why Orchestrate is useful. So basically, so in terms of architecture, Hyperledger Besu as an Ethereum client mainly does three things. I will start with the first one on the right, which is networking. So it's the ability of the client to create a peer-to-peer network and communicate information with its peers. Then on the left, the storage, so the ability to store some data. So basically, the data associated to the smart contracts that will be running in an Hyperledger Besu network. And then in the middle, what we name the Ethereum core, or more commonly, so which is basically related to the consensus algorithm. So how those Ethereum clients together can find a consensus over the transaction ledger. And what we name the EVM, or the Ethereum virtual machine, which is basically a system to execute the transactions. And then on top of that, you have what we name the JSON RPC, which is basically an API to interact with an Hyperledger Besu node. So it's a way another system that needs to interact with the blockchain would be able to do so. So it's through the JSON RPC API. So what is important to remind here is that basically Hyperledger Besu, as any blockchain client, is a software that is able to execute the transaction in a decentralized fashion. And we will see this interesting because it makes sense. So the orchestrate side will be how do we create those transactions and manage those transactions, not executing. So how you can contribute to Hyperledger Besu? So you are very, very welcome to contribute. There are many fashions to contribute to Hyperledger Besu. In particular, we have a contributing guide on the Hyperledger wiki. Almost everything is documented there if you want to raise issues or even maybe contribute to the code base by sending some pull requests. I'll be sharing the deck, so you will be able to find those links. So now switching to PegaSys Orchestrate. So PegaSys Orchestrate is a platform that enables to build secure and reliable application on the Ethereum blockchain, in particular on Hyperledger Besu. So Orchestrate is compatible with all Ethereum-based protocols, but in particular, it combines effectively with Hyperledger Besu to provide some extra features that are in most cases required by an enterprise platform that wants to build on top of the blockchain technology, and in particular on top of Hyperledger Besu. So more technically, what we'll say is that PegaSys Orchestrate is a middleware, and some business application will be able to connect on top of this middleware and get some complexity to use the blockchain abstracted. And so, and the part of the complexity that is being abstracted is around transaction management, account management, and private key storage, around onboarding of blockchain nodes, compatibility with private transactions, so using Besu and Orion, the ability to get smart contracts, so get compatibility with smart contract with a smart contract registry, and then more around characteristics around multi-tenancy and high availability. So what I propose is to focus a bit on those features, try to explain a bit better what they mean, and maybe comment a bit in some context of enterprises when we have been working on those features and why they have been useful for us. So first, around transaction management. So as I mentioned earlier, Hyperledger Besu, which is your blockchain network, is a layer that can execute the transactions in a decentralized fashion and include it in a ledger. We often say mining transactions when we are speaking, mining transactions. But it does not generate those transactions. Those transactions usually need to be generated outside of Hyperledger Besu in another applicative layer. So this is the role of PegaSys Orchestrate. I will not necessarily deep dive in what exactly means managing a transaction, but it basically is generating the transaction, signing the transaction, so using a private key, sending the transaction to the blockchain network, and then once the transaction has been mined by the blockchain network, catch the receipt of the transaction and possibly post-process this receipt. And so this is a feature that we have been already, so on all the projects that we have been working on, this is a feature that you always need to build. And here, for example, you have some complexities related to for example, the nonce management that are often complicated to solve and that are inducing some innovation risk on the projects and on building those blockchain platforms. So yeah, so this is the first feature is around transaction management. Then we have we are working on second aspects, which are around account management and private key storage. So here it consists in we know what is an account in the Web2 world. So for example, a Gmail account, and we have on the blockchain some blockchain account or Ethereum account when we are speaking about Ethereum with Hyperledger Besu. And those accounts are actually related to a private key. So it is so first you need to be able to manage those accounts, and then you also need to store those private key in some secure systems. So for example, we are working with a secret store that is named HashiCorp Vault. So it's a software to store secrets very securely. And it's really, very important that we get a strong security over the private keys, because basically if some, let's say, hacker get access to a private key, then it could behave as the original owner of the private key. So we could imagine, for example, in some financial systems, someone getting the ability to do a transfer for someone else. So then around the onboarding of the Hyperledger Besu node. So when you have a platform and you have your Besu nodes running as your blockchain network, you often need to add or remove some nodes. It can be, for example, for maintenance or operation reasons. And this process can be quite significantly complex to achieve without having to, for example, stop the platform. And so here we have been working on giving the ability to orchestrate, to facilitate the onboarding of new Besu nodes. So facilitating, creating, or adding nodes to an Hyperledger Besu blockchain network. Then another feature which is important, which is around the smart contract management. So here, basically, when you are building a decentralized platform, you will use some smart contracts that are the programs that will run on your blockchain network. So here, in our case, our Hyperledger Besu network. And basically, for your application to be able to create transactions, it needs to be compatible with the smart contract. And so how do we facilitate that is by providing a contract registry that allows to store the smart contracts. And so from the moment the smart contract is stored, an application will be able to create, to generate transactions for the smart contract, or for example, decode the receipts of the transactions when they have been made. So then, coming back a bit for the privacy compatibility with Hyperledger Besu and Orion. So Hyperledger Besu is the Ethereum client. Orion is a second piece of software that we are working on at PegaSys, which is open source as well. That is a private transaction manager. And basically, when you are using the combination of Besu plus Orion, you can create a model for privacy based on privacy group. So what does it mean? It means that usually when you are in a blockchain network, when you are sharing information through a smart contract, you are usually sharing this smart contract with all the nodes in the network. With Besu and Orion, you can create the concept of privacy groups, allowing to share some information only with a subset of nodes in the network. So for example, if we look to the diagram on the left, you can see here that we have two privacy groups, one with the nodes A, B, and C, and the second one with the nodes A, D, and C. And meaning that the information that is shared in the privacy group ABC cannot be accessed by the node D, and same what is shared between A, C, and D cannot be seen by the node B. So this is typically useful if we try to take a business example. So if you are, let's say, an asset manager, and that you want to create, so to basically tokenize some financial assets, some of your assets, which are basically the share class of a fund of yours. and you need a transfer agent to have, and a fund administrator, and some external actors to have access to this information, but those balances of your share class should not be accessible by all, then you would choose this type of privacy model, creating a privacy group only between the asset manager, the transfer agent, and the fund administrator, but not for typically another asset manager that should not have access to the balances of your fund. And so why it relates to orchestrate, it's because, of course, those privacy models induce some complexity to be able to be properly leveraged. And so orchestrate completely combines with Hyperledger Besu to facilitate the usage of this kind of privacy models. So another feature that we have been seeing appetite for is the multi-tenancy. So the multi-tenancy is the ability of a single system to serve multiple different parties and providing some restrictions so those parties cannot basically share the same data. So first, why it's interesting, why the multi-tenancy model is interesting, it's because it allows with one software instance to serve multiple users or parties, and so basically you get some optimization on your running costs because you do not need to have one software running per party, but you can have one which is shared between all those parties, but still those parties get a strong guarantee that they will not be able to access the information of each other. So this is typically useful when you are, for example, in a consortium where you have, let's say, hundreds of members, and in those members, some cannot afford to pay for a full entire stack blockchain infrastructure running. So what we do is basically we allow multiple members to share one single stack, but we provide them with strong guarantees that they will not be able to access the data of each other. So in particular, when we are speaking about an Hyperledger Besu network, and if we look to the diagram on the left, each tenant, so for example, here let's imagine a consortium of bank. So each bank would have its own tenant with its own access to an Hyperledger Besu node, and with its own private keys in HashiCorp Vault and its own smart contracts. So this is mainly to optimize the running costs. Then about the resiliency of an infrastructure. So when you need to build a resilient infrastructure, what we usually do is that we replicate the applications. So we get what we name high availability in multi-availability zone active-active deployment, which means that basically you have multiple data centers in different geographies. You can deploy your software over all the data centers. And if in case one of those data centers crashes, so let's say, for example, you were deploying an application in the Europe West geography of AWS and one other in the Europe East, then when the Europe West will crash, the other region will still be running the software, so it will be available to still serve an application. So this is typically useful to make sure that, for example, when a user get access your platform, then it will always be sure that you will be able to serve the user request. And also, second thing which is important is regarding the possible loss of data. So basically, what also is important to ensure, and it's that you cannot lose a transaction. So basically, when the application requests for a blockchain transaction, it should be there should be a strong guarantee that this request will actually result in a transaction which is mined by the blockchain. So typically, it's important. So, for example, when we have been working with financial system, when you are receiving and using, for example, and you're receiving, for example, a message that an order has been executed or matched when we are speaking about an exchange, possibly, then usually you send a message to your blockchain platform saying, please trigger the DVP for this order that has been matched on the blockchain. And you should be sure that the DVP will be actually executed. So if you want to know more about Orchestrate, I've put some links there that you will be able to access in the deck, in particular for the documentation of Orchestrate. And yes, that's it for me. Thank you very much for your time. And if you have any question, I will be very glad to answer.
Okay, Nicolas, thank you very much for that wonderful presentation. And now I'd just like to open it up to the group to ask questions for any one of the two presenters here about, I saw a few come through on the chat. So if you just want to unmute yourself and just ask a question, let's kick it off with that.
Sure. Jim Mason for Nicolas. Question, both Orchestrate and Orion and the other frameworks are all open source Apache 2.0 license, is that correct?
So Hyperledger Besu is open source Apache 2, Orion is open source Apache 2, Orchestrate is license based. So yes, it is, and then PegaSys is also working on PegaSys Plus, which is an extension of Hyperledger Besu, which is also license based.
And you don't have any consensus models that are not simple proof of authority or proof of stake? You don't have a pluggable consensus model, correct?
So Hyperledger Besu is compatible with proof of authority. So we support two consensus algorithm. So the main one that we are using is IBFT2, but we also support Click and IBFT1. That's the origin.
Thanks.
Hey,
Yeah,
Nicolas.
I think we also, go ahead. Yep, Mike, I think had a question.
My name is Mike McCoy. I had a question. Are you familiar with blockchain integration framework, which is based out of Hyperledger Labs?
How it's named, sorry?
Blockchain integration framework. It's based out of Hyperledger Labs.
Okay, I would be glad getting the reference.
Never mind. I just I've heard of similar functionality between integration framework and I guess you would consider Orchestrate or Plus, in as far as like key management, as far as being able to utilize similar type of functionality. But would you be able to say that Orchestrate, has there been any in your experience with enterprise adoption or input, has there been any particular issues other than universal labeling and or trying to connect to different data sets of combination between partners? What are some other challenges when implementing these type of tools for larger data sets or for larger environments?
So usually what we see is so the kind of architecture that we are seeing more and more adopted is usually so you get your blockchain, so you get multiple parties that are either running their own infrastructure, so basically their own stack in their own AWS or Azure or any cloud. I'm basically saying that they are running their own software. You see this kind of shared infrastructure between multiple members of a consortium. So, and all these together can form a blockchain consortium. And so you will have all this communication going through the blockchain. And then we are seeing more and more communication also going as off-chain communication. So basically those stacks speaking together to exchange some information that is private and that should not appear on the blockchain network, basically. And yes, so and then so basically the storage of data can be either on the chain or on some more regular systems such as SQL databases or yeah, this kind of stuff.
Okay, I think there are some other questions that came through chat. There's one about would the concept of private contracts be included in Hyperledger Fabric just as private channels and PDC? So I don't know, Dan, maybe you want to take that one?
I don't know if I want to touch that one. That sounds like a how is Fabric different to Besu question. That's probably not my
Not your.
expertise.
Okay, no problem. Do we have any other questions that we want to put forth?
Sure, Jim Mason, one last question for you, TPS.
Yep.
Any benchmarks so far?
Excuse me, the sound has been freezing a bit. If you could.
Would you like to repeat that question?
Yeah, just have you done any benchmarks on, I'll call it the Orchestrate framework at this point, in terms of, TPS for any standard benchmark cases you've got?
No proper benchmark has been done yet. The architecture design of Orchestrate relies a lot on Apache Kafka, for those who are familiar with this technology, which is a message broker that allows to horizontally scale an application. So basically saying that if we need to deal with more traffic, we can replicate an application and have two applications dealing with this traffic. So we do not get proper benchmarks, but we have a design that should allow quite heavy horizontal scaling because we are relying on Apache Kafka.
Okay, other questions that we have from the audience? I have one question for Dan. Now, when you're working with one of the oldest, or I guess the oldest standards bureau, how do you feel about their receptivity to such a 21st century contract as a smart contract from the Accord project?
Yeah, I mean, I'll probably as a technical author, my biggest frustration with working with them was their insistence that we use Microsoft Word, which when you spend all day in GitHub and Google Docs is fairly frustrating. But I think it is indicative of the stranglehold that technology like Microsoft Word has over particularly the legal community. So I think we're pretty realistic. We know that we're not going to wean them off Word overnight. It's going to take time. But I'm hopeful that we can bring them onto technologies that are more modern, that allow more collaboration and that have more semantics, which is, all of those things are pretty lacking in the legal space right now.
Perfect. I think Claudio has one other question for you as well. He's asking about, is Hyperledger Fabric the preferred way to implement Accord legal smart contracts?
I wouldn't say preferred, because we are scrupulously kind of neutral in this, but we're an open source project, right? So we're the pace that different features progress is largely dictated by the itch that people have to scratch and the contributions that we get. So it's fair to say that the Fabric support for AP templates is furthest along the track. So at the Hyperledger Global Forum, which was the last in-person event that I did in Phoenix, I gave a live demo of an Accord project template running on Fabric. So there's a pretty nice GitHub repo that you can pull down and get that running on 1.4 pretty easily. But we have also done work with R3 and Corda, primarily because they stepped up and an engineer got involved and put some blood, sweat, and tears into the project. So that pushed the Corda support forward. I would love to get more engagement with the Ethereum community, and so we have a Google Summer of Code proposal open at the moment to build a eWASM or WASM backend for the Ergo language. So we would love to be able to compile Ergo to WASM, and then we could start to experiment with deploying it on Ethereum 2.0 kind of technology. But it's open source, right? You get out what you put in, essentially.
Perfect. Okay, any other questions that we have for either Dan or Nicolas? Okay, everyone. Well, I just want to tell you thanks for joining this virtual meetup. This is the first one we tried here. And so I appreciate everyone joining in and trying it again. And what I will say is let's wrap it up for today, and then we'll come back and we'll have a new virtual meetup at some time in the near future. So thanks, everyone.
Thank you, John, for organizing. That was great.
Thank you very much. Cheers.
Thanks, John.
Good job, Nicolas.
Thank you, Dad. Cheers, all. Be safe.
Thank you, guys.
À bientôt.
À bientôt.